Begin recording 2 for Project Vitalis. I am Dr. Talia Hawthorne, lead botanist for the Institute for Vegetative Yield, or IVY, under the Omnitech Research Group. This is a continuation of our previously submitted audit for the Royal Archive for our autonomous unit dubbed Vitalis. Vitalis will explore the anomalous dangers of Neocity Zero, with a priority on discovering resilient plant species surviving within the unprecedented radiation at major points of interest. Our work is made possible by essential data provided by the Royal Archive, as well as PCBWay for enabling access to previously unattainable systems. PCBWay offers advanced 3D printing, PCB prototyping, and manufacturing services, making it easy to create custom, intricate components. This allows Vitalis to be equipped with specialized parts and undergo thorough testing before critical field deployment. Thanks to PCBWay's support, we've been able to design a fully equipped test platform that wouldn't have been achievable otherwise. The first test platform was a failure due to overcomplication. We underestimated the effects of radiation, causing the platform to melt before concrete could be poured into the molds. We revisited the design and prioritized building a solid foundational slab before integrating additional systems. The second test platform provided valuable insights, but the third iteration achieved optimal results. Version 3 of the test platform featured a robust, streamlined foundation with separate installations for complex components and radiation shielding. Unfortunately, this FDM construction was very poorly quality controlled and needed many hours of manual labor to address. While calibrating the radiation test platform, a man appeared, almost materializing from thin air. No introduction, only the Dominion badge glinting from his cloak as he spoke in vague, deliberate phrases. He barely looked at the data, as though he already knew the outcome, then reminded me, in no uncertain terms, to document every finding with exacting detail. I assured him the platform's design had been tested for the highest gamma levels and environmental extremes were accounted for. He stepped closer, hovering a gloved hand just above the platform's surface, never making contact. His presence carried an authority that went beyond any Dominion agent I'd ever met. Eyes fixed on the platform, he murmured, as though to himself, "Keep an eye on Vitalis. Sometimes, in our drive to understand the environment, we overlook what it understands of us." Before I could respond, he was gone, as swiftly as he'd arrived, leaving me with the sense that this wasn't just a routine inspection. Vitalis's mission may hold far more weight than I'd imagined. Though his words still resonate in my head, there was work to be done. I refocused on the task at hand, ensuring every part was in place. After addressing each defect, the platform shielding was mounted to the foundation using a polyvinyl acetate sealant along with stainless bolts to dampen vibrations. A final polish with cyanoacrylate to fill the worst gaps was enough to complete the platform. The components ordered from PCBWay matched our specifications precisely, for better or worse. An oversight left certain components requiring manual removal using available tools, including precision cutters and abrasive surface trimmers. Once all parts met the final design specifications, we proceeded with surface preparations. A medium-grade isopropanol solution and an industrial-grade oscillating surface actuator were deployed for comprehensive decontamination, degreasing, and particulate removal on all components designated for integration with either the Vitalis system or the new testing platform. To prepare for surface treatments, high-tolerance masking films were applied to shield all critical moving parts, such as bearings and actuators. Each component is secured on a precision alignment rod, allowing for full rotational access and suspended isolation during the coating phase. A precision bonding matrix was employed to secure large components to appropriately sized rods for optimal stability and alignment. The largest components were mounted on stability-enhanced support blocks to provide a fixed, elevated base and prevent unintended contact during the coating process. While the Vitalis unit could be mounted on the blocks, the lack of automatic braking in the ankle joints while powered down posed a risk of the machine toppling during subsequent operations. To secure the massive test platform, ethylene vinyl acetate was used to create a durable yet removable bond. Surface treatments had to be applied in a specialized facility outside of the Institute's location. Due to VOC hazards, observers were required to wear personal protective equipment. Substrates were meticulously filtered to remove contaminants before applying their initial protective coatings. A general-purpose ionizing-resistant bonding agent was applied to all systems and subsystems. While this coating alone cannot provide comprehensive protection against severe radiation threats, it represents the most effective available solution for our current needs. Every layer of defense, no matter how thin, contributes to the overall capability of the equipment. This coating is then cured in an insulated kiln with heavy airflow to ensure maximum effectiveness. The same facility is used to electrostatically apply a magnesium-fortified polymer to increase radiation resistance and durability. A humidity-induced degradation coating was applied to all specialized and moving parts in order to remove overspray of future coatings that are still needed on components. Lastly, titanium dioxide was applied across the Vitalis unit wherever it would not interfere with sensors or mechanical systems. Titanium dioxide's high melting point will prove useful in shielding against intense gamma radiation, while providing high corrosion and weathering resistance, both ideal for NeoCity Zero. Following the completion of all surface treatments, the machinery was successfully retrieved and transported back to the Institute for thorough cleaning and performance testing. The components sourced from PCBWay have proven to be highly durable and reliable, enabling extended operational life despite significant use. The testing platform, though showing signs of wear, remains structurally sound due to the durability of the hardened plates. As mentioned previously, the EVA can be debonded using isopropanol. Following the polishing of the diagnostics panel, individual switches, LEDs, gauges, and measurement circuitry were installed according to the specified design. Although I was tired, I was still feeling confident and able with the Vitalis experiment. With all equipment preparations finalized, we were finally able to finish cleaning up the robot itself and begin testing, both in the field and with the new radiation test platform. Water, like food and fuel, is a valuable and limited resource within the Omniplex. Despite the risks, we opted to use this with a humidity-induced degradation coating to selectively remove titanium dioxide from critical areas, preventing potential system failures. The results exceeded expectations, but further refinement of the technique is possible. The Vitalis robot was painted with the Institute's standard green and marked for easy identification in case of discovery. A high-temperature, non-flammable lubricant was applied to all moving components. Minor cosmetic imperfections, resulting from incomplete masking, were easily rectified. Several standardized required markings and warnings were applied to the machine. Vitalis was released into the surrounding urban environment to test navigation and discovery protocols. A minor dust storm impacted the Omniplex during this outdoor operation, resulting in superficial scratches to the unit's exterior. Our primary objective is to identify scalable crops for the Neocities. Based on Royal Archive data, there's a strong likelihood of discovering resilient plant species within the hazardous ruins of Neocity Zero. Despite the botany department's focus not being within the realm of robotics, the test platform has proven successful in conducting intense radiation experiments. Additionally, the Vitalis unit has maintained optimal operating temperatures during these rigorous trials. May Vitalis uncover solutions that will benefit the entire Omniplex. All we can do is seek progress, not perfection. Infosphere analyst cost has been reduced. Thanks for the support. End recording 2.